normal distribution and the z-score, the other name is the bell curve. So from there to there is actually 34. So you have that. So that's going to be 34 again. So whatever is left, so in between from here to there is 50%. You have 50 percentile and another 50. So that's below the mean. And that's above the mean. Above the mean. And the mean is x bar. And whatever is left, so from there to there is 16%. So now here the 95. So from there to there is 2.5%. And the second one, that's going to be another 2.5 out of the 100. So now here we have also the 99.7, so it's going to be 0.015, this bit there. So the z-score, so at that point the z-score is 0, standard score. And this is the formula we use. So this is the x is the actual score, and the x bar is the mean, x bar is the mean or the average, and Sx is the standard deviation of the sample. The higher the z value, the better the result is. Actual score, which is the x value, so equals to mean, which is the average, plus standard score times z. Alright, let's have a look at an example based on this concept, the 95. And we also need to understand that 68 percentile is the mean plus or minus 1 standard deviation to the left and to the right. So the 95 is 2 standard deviation. The plus it or minus is 2 standard deviation. 99.7 is 3 standard deviation. So you multiply by 3. Alright, let's have a look at an example based on this concept. Alright, the mean concentration span of a group of students tested is 49, and the standard deviation is 14 seconds. Calculate the values between which we would expect the 68. So the 68, we said that it's 1 standard deviation, so it's bar, plus or minus 1 standard deviation. So the mean is 49. Which gives me a value of 35, 63, and the 95. X bar plus or minus 1 is 2 standard deviation, so that's going to be 49 plus or minus 2 times 14, 14, which gives us 21. So one time you subtract, so 49 minus 2 times 14 gives me 21, 77, 49 plus 28. That's 28 anyway, 77. Alright, so let's do C again. So 99.7% x bar plus or minus, this is 2. So that is 3 times the standard deviation, which gives us 49 plus or minus 3 times 14. Alright, let's have a look at another example. The foot length of a sample of 2,400 women are approximately normally distributed with a mean of 23.8, standard deviation of 1.2. What's the expected number of women of these women with foot length less than 21.4. So we need to make a rough sketch just to give us a picture of how things look like. So now here, this is your X bar, which is 23.8. Standard deviation is 1.2. What is that? So that's going to be, less. So it's obviously less than, so it's going to be towards the left side. From there to there, it's actually 34. So that's going to be 23.8 minus 1 is standard deviation, which is 1.2. So that gives us 22.6. So the next one will be 21. And then remember that the next one will be the 95th percentile. So one standard deviation is going to be the 68, and the second standard deviation is the 95 percentile. So whatever less than that, so it's going to be 2.5. So now we want to find out what is the expected number of these women. So that's going to be less than 21.4. It's going to be 2.5 divided by 100 times 2,400. So that gives us 60 women. All right. So let's the 60 women. All the standardized foot length of one of these women is that. What is the actual? So now we're trying to find out the x. So we know that this is the formula. So we're trying to find out what x is. So that means negative 1.3 times the standard deviation, which is 1 point, plus the mean, which is 49. That's what x is, actual length. And we've seen that formula before, which is this one here. So this is what you're supposed to be using. This is the formula you're supposed to be using in order to answer that question. All right. So 47.44 centimeters. That's the actual. All right, let's have a look at the other example. The time in hours for each student spent sleeping was recorded for 1,550 secondary school students. The distribution of this time was found to be approximately normal, with a mean of 7.4 hours and a standard deviation of 0.7. What is the time? What is the time that the 95% of these students spent sleeping on a school night? So the 95 is 2 standard deviation. There today is the 68. The 95 is 2 standard deviation. So with the 95 percentile, so the average, which is the mean, plus or minus 2 standard deviation. So the mean is 7.4, plus or minus 2 times 0.7. That gives us 1. So they spend about 6 hours, between 6 hours and 8.8 hours. All right. so let's do the last example. A class of students set for a bio test and a legal studies test. Each of these tests has a possible maximum score of 100 marks, and the 100 marks, the table below shows the mean and standard deviation of the marks obtained in these tests. The class marks in each subject are approximately normally distributed, and Sashi obtained a mark of 81 in bio, the mark that Sashi would need to obtain in legal studies test to achieve the same standard score for both legal and bio is. So we need to find out. So now her bio test was, that's the actual, so we need to find out the Z score, which is this one here. So we know that this is the mean and that is the standard deviation. I want to work it out what the, all right, now the actual score is 81, 54 over 15. So that gives us a Z score of 1.8. And now we want to work it out, what does she need to get the same. So that's going to be the actual score. Actual score for legal equals to the standard deviation times the Z times standard deviation plus the mean. So the mean is for legal and the standard deviation stuff. So that's going to be 1.8 times 5 plus 78, which is she needs to get 87 score. And that's it for normal distribution.